Hello friends, myself is Gandhar Kumar. I am taking Power Electronics for 5th semester electrical engineering students. In the previous lectures, we are discussing the various things about related to the power electronics, and today we are discussing about the methods of computation. Methods of computation means how to turn off the power electronics components and how to shut down the circuit for the application which will be operating with the help of the power electronic device. The turn-off process of an SCR is called the commutation. The term commutation means the transfer of current from one part to another. So it will be a commutation of SCR, it may be a commutation of track, it may be a commutation of the other devices which will be associated with the power electronic devices or the devices which are operate on the high voltage and the high current. So the commutation circuit does this job by reducing the forward current to zero so as to turn off the SCR or thyristor. To turn off the conducting SCR, the below condition must be satisfied. First, the anode or forward current of SCR must be reduced to zero or below the level of holding current, and then a sufficient reverse voltage must be applied across the SCR to regain its forward blocking state. When the SCR is turned off, by reducing the forward current to zero, there exist excess charge carriers in different layers. The regain the forward blocking state of an SCR. These excess carriers must be recombined. Therefore, this recombination process is accelerated by applying a reverse voltage across the SCR. The SCR turn-off methods are the reverse voltage which causes to commutate the SCR is called commutation voltage. Depending on the commutation voltage located, the commutation methods are classified into two major categories. First is the forced commutation, second one as the natural commutation. Let us discuss all these methods in brief. First method will be considered as a natural commutation. In natural commutation, the source of commutation voltage is the supply source itself. If the SCR is connected to an AC supply, at every end of the positive half cycle, the anode current goes through the natural current zero, and also immediately a reverse voltage is applied across the SCR. These are the conditions to turn off the SCR. This method of commutation is also called as source commutation or line commutation or class F type commutation. This commutation is possible with line commutated inverters, controlled rectifiers, cycloconverters, and AC voltage regulators because the supply is the AC source in all these converters. So under this one, if the AC source is using, then the natural commutation will be takes place because after a specific time, the negative signal will be flowing towards the source from the source. Now this will be the circuit. Over here we are given the supply voltage. SCR is connected. SCR is fired by using the firing circuit. It may be R firing, RC firing, or UJT firing. Any kind of firing we can use just to turn on the SCR. Then there is a load will be connecting and the load current will be flowing through this. So the positive half cycle, the supply is moving from the SCR towards load and the source like this, and at a specific angle the SCR is turned on, so we are getting that the output voltage it will be moving from a specific firing angle up to the point where the waveform is reached up to a 180 degree. Just whenever it will be moving towards the negative side, we are getting a reverse supply from this end, and that reverse supply is just to work on, just to turn off the SCR because the positive supply is turned off and the negative supply is going on and the device is automatically turned off itself. Next will be the forced commutation. In case of DC circuit, there is no natural current zero to turn off the SCR because in case of the DC supply, we are not that the supply is always in the positive arc, not in the negative arc. So at that moment, there is no turn off will take place in natural format. In such circuits, forward current must be forced to zero. with an external circuit to commutate the SCR, hence named as forced commutation. This commutating circuit consists of components like inductors and capacitors called as commutating components. These commutating components cause to supply a reverse voltage across the SCR that immediately brings the current in the SCR to zero. Based on the manner in which the zero current achieved, an arrangement of the commutating component post commutation is classified into different types such as class A, class B, class C, class D, and class E. This commutation is mainly used in chopper and the inverter circuit, where the main source of supply is DC. Class A type commutation, this is also known as self commutation or resonant commutation or load commutation. In this commutation, the source of commutation voltage is in the load. This load must be an under-damped RLC supplied with a DC supply so that natural zero is obtained. The commutating components L and C are connected either in parallel or in series with the load resistance R. The waveforms of SCR current, voltage and capacitor, it will be discussed in the later on. The value of load resistance and commutating components are so selected that they form a under-damped resonant circuit to produce natural zero. When the thyristor or SCR is triggered, the forward current starts flowing through it, and during this the capacitor is charged up to the value of E. This will be the circuit diagram where we are getting that there is two types of connections are there. In first one, we are assuming that the inductance and the capacitor are in series and resistance. It will be connected in parallel with the capacitor. Second circuit, there is the RLC are all connected in series with each other. So at initial stage, whenever the supply is going on, we are just giving the gate pulse, SCR is turned on. While the SCR is turned on, then automatically the supply is moving towards from the inductor, then capacitor, so inductor will be charged and the capacitor will be charged. As the capacitor is fully charged, then automatically it will oppose the source through which it will be charged. So it will oppose it and generate a negative polarity across the cathode point of the SCR. So automatically the flow of the current it will be stopped or it will be below the holding current and automatically the SCR is turned off. And this capacitor will be discharged with the help of this resistance. So the value of this resistance it will be indicated that how much time will be taken by the capacitor to turn to discharge itself. Similarly, in this case, we are finding that in the second circuit, the same process is going on. LCR are in the series, and once the SCR is turned off with the help of the gate pulse, the supply current will be moving from the L, C, and R capacitor will be charged until the capacitor is reached to the fully charged. It will reverse bias itself, and the supply is reversed and moving towards the SCR. So the current which will be flowing through this, it will be below the holding current, and capacitor is responsible just to turn off the SCR. These are the waveforms which we are deliver over this side. We are getting that at the input side there is a gate pulse, capacitor charging. It will be moving from this point to this one, and then it will be discharged. So the timing of the charge and discharge of the capacitor it will depend upon the circuit. In the first circuit, we are getting that the RL will be applicable just to discharge the capacitor. In case of the second one, the discharging rate will be reduced because the circuit will be completed through the SCR. And at that moment, only the leakage current will be flowing through the SCR while the SCR is under the off stage. So the SCR waveform we are getting it will be operating for the positive half only, and this one and for the negative part whenever the capacitor is discharging there is no signal we are getting from this side, and over this side whenever we have to just look over the voltage across the SCR, we are finding that until unless the SCR is turned on, then till that we are getting the particular waveform. This waveform is just close to the gate current. While the gate current it will be given, the SCR is turned off. When the SCR is turned off, we are getting a zero voltage across the SCR. So this is the T of time, and at that moment we are again getting a signal in the negative reverse bias because the SCR is goes to decline and towards the making it to a close, open. So at that moment, some signal are moving from this side, and again it will be reached up to this point and give you a particular value for the negative half cycle, or we can say that while the SCR is not turned on, then we are getting a positive signal at the point. Once the capacitor is fully charged, the SCR becomes reverse biased and hence the commutation of the device. The capacitor discharges through the load resistance to make ready the circuit for the next cycle of operation. The time for switching off the SCR depends on the resonance frequency, which further depends on the L and C components. This method is simple and reliable for high frequency operation, which is in the range above 1000 Hz. This type of computation circuit is preferred due to the high values of L and C components. Now this will be the end of the first computation process of the class A type computation. In the next lecture, we will discuss about the another method which will be associated with the computation of the SCR. Thank you.